And welcome back to Mr. Gregoris Math. Today we're looking at solving inequalities. So we have here an inequality up on the board, and we're asked to solve and draw the solution. Now solving an inequality is like solving an equation. We just kind of follow the same algebraic steps. Our first step is to distribute the coefficient through the brackets. So we'll have 2x plus 2 is greater than 5. We're going to continue to solve this using opposite operations. So we'll remove 2 by subtracting 2, and what we do to one side, we have to do to the other. Those cancel, neat and neat. And what remains on the left is 2x, and what remains on the right is 3. So we have one last step, and that is to isolate x, so we need to get rid of multiplying by 2. We'll divide both sides by 2. This will cause these to cancel, neat and neat. And on the left, we'll be left with x is greater than, and on the right, we'll be left with 3 over 2. So that's the first part. We have to solve it. And this is the solution set. But the next part is to depict it, because it's not one single point. We're going to go ahead and draw ourselves a number line. So we'll draw the real number line. I'll label it with that funky R that tells you you're talking about the real numbers, and here's 0. So my boundary point is 3 over 2. So I'm going to go ahead and plot my boundary point. It's to the right of 0, so we'll just put it there and write 3 over 2, so we know that we're talking about the boundary. And because we're looking for values greater than 3 over 2, we'll check and see values kind of all the way along the number line. Well, is 0 greater than 3 over 2? I don't think so. I think that's incorrect. So 0 is not a solution. So that means I need to actually shade everything away from 0 in my solution set. So everything goes from 3 over 2 to the right. And because I have an inequality that doesn't have an equal sign, I'm going to include an open dot on 3 over 2. So that open dot on 3 over 2 says, don't include 3 over 2, but include everything to the right. And so that's how we can solve and draw the solution for one inequality. We'll do a slightly more complicated one now that shows one of the unique cases. So same style of question, we're going to solve and draw the inequality. But my question is, negative 4x plus 1 is less than or equal to 9. So this is slightly different. The algebra is perhaps easier, but there is a little bit of a trick. So I'm going to subtract 1 from both sides. And subtracting 1 from both sides, I'll have 8 is less than 4x. And now I have to divide by negative 4. Now when I'm solving inequalities, if I divide or multiply by a negative, I need to change the direction of the inequality. And that's because right now 0 solves this, right? Negative 4 times 0 is less than 8. But if I divide by negative 4 and don't change my inequality, then I would have 0 is less than negative 2. And that's not true. So I have to be careful. When dividing by a negative here, I know that I'm going to have to cross out my sign and change its order. And so I'll have x is greater than or equal to, and 8 divided by 4 is negative 2. So now I know my solutions. X is greater than or equal to negative 2. I'll go ahead and draw them on a graph. So same idea. I'll graph the real number line here. There's 0. I'll make a mark at negative 2. That's my boundary. And I know it's greater than negative 2, but let's check it. Is 0 greater than negative 2? Yes, I think it is. So I'm going to shade towards 0. And because it's an equal sign, I'll use a solid dot at negative 2. And that's my graph solution for this particular inequality. Ladies and gentlemen, don't forget to hit like, subscribe, and smash that notifications button. Please do not comment because this video is made for kids. But if you check the link in the description, you can get to our merch store to sign up for all the good things you need. Thank you very much. We'll see you next time on Mr. Gregoris Math.